In the previous movie, we saw the importance of using gimbal coordinate system when rotating a free camera. Now let's go a little bit deeper and talk about rotation axis order. That will help us to emulate the mechanics of a real-world tripod. Gimbal mode accurately represents the complex interaction of rotational axes. These are what's known as Euler angle rotations, named after the mathematician who developed this math in the first place. The three rotation values are calculated sequentially in a particular order. That results in a kind of inheritance in which the orientation of the rotational axes depend on one another. So to illustrate, in gimbal mode, if we rotate around a particular axis, the other axes may or may not inherit that rotation depending upon the rotation priority. So for example, if I rotate around the y-axis in gimbal mode, the x-axis follows, but the z-axis does not. And that's because of the rotation order. Behind the scenes, these rotations occur one at a time, and they influence one another in sequence. With the default rotation order of x, y, z, first we rotate in x, then in y, and finally in z. Earlier rotations are affected by later rotations. The later rotations have a greater effect over the result, and so they're said to have a higher priority. If the rotate order is x, y, z, then z has the highest priority. So if we rotate around z, we see that the other two axes follow. X has the lowest priority. If we rotate around x, we see neither one of the other axes follow. And if we rotate around y, we see that x inherits from y, but z does not inherit. Knowing that these axis rotations actually affect one another, we can now set up the rotation order to emulate a tripod. So for a tripod, pan is the most important axis, followed by tilt, and finally the Dutch tilt, or rotation along the line of sight. That tells us that the optimal rotation order for a max camera is y, x, z. Okay, so let's set that up. I'll restore these rotations back to neutral. Set the x rotation value to 90, press tab and set the y rotation to 0. Okay, let's change the rotation axis order. That'll be found in the motion panel. We haven't seen that one yet. Looks like a little circle or a wheel. Within the motion panel, we want to be in the parameters panel. Under PRS parameters, click rotation to reveal the rotational parameters. And right at the top, we have Euler parameters and the axis order. And click on that to reveal the options down here. We're looking for y, x, z, and it is in the list. But ironically, we don't want to choose y, x, z. And that's because Max uses a different naming convention, which is based on a mobile frame of reference. I don't want to go too deeply into the weeds here, but Max uses the mobile naming convention, where the orientation of the frame of reference is reevaluated between each calculation. The optimal order for a camera using this mobile naming convention is ZXZ. This does not mean that Z is being rotated twice. It isn't. What would have been a Y rotation relative to the fixed frame is now a Z rotation relative to the mobile frame. So we'll change this to ZXZ, and changing the axis order changes the outcome of calculations. The X, Y, and Z values down here didn't change, but the end result did. The camera is now pointing straight down. So let's fix this. We'll set the X value to 0, press Tab, and set the Y value to 90 degrees. And now we're back where we were. And we've got the optimal rotation order now for a tripod. Z, or pan, is the most important axis here, and the other two axes follow. X is tilt, and we see when we tilt, the pan axis doesn't change, but the Dutch tilt, or canted angle, or rotation around the line of sight, does change when we rotate around X. All right, and then finally we can introduce a Dutch tilt in the least significant axis, or the lowest priority axis. And when we rotate around that y-axis, we don't see the X and Z axes change. Okay, we can restore this back to neutral, rotate back around Y, and we see the Y value change down there. But just be aware that the actual rotational space here is world coordinates, and the values we need to plug in to restore the object back to neutral may not make a lot of sense initially, but you just need to know that the X value should be 0, and the Y value should be 90 degrees. That'll restore your level horizon line. And that's happening because we're using the gimbal coordinates as a way of adjusting the world coordinates. Since this object has no parent, all of its rotation values are going to be stored relative to the world grid. That's how to set up the optimal rotation order for a free camera.